How's it going, guys? Today in this video, we're going to be going over 11.4, day 2, writing cube root functions from a graph, and also modeling cube root functions. So let's go ahead and just get started. On this problem here, what we want to do is we want to figure out what the function is going to be in the form g of x equals a times the cube root of x minus h plus k when we're given this graph on the right. So what we're going to do, or rather the first thing we should do, is we should look for our hk value. So our hk value is going to be the point in the middle of when the graph starts to shift more vertically. So when the graph starts to change shape and become a lot more steep and starts to shoot more upwards, like we see right here in the red, that middle part, or sorry, like the middle point of that more vertical part of the graph, that's going to be your hk point. So in this case, our hk point is 1, 7. That point right in the middle of that vertical part is 1, 7. So that's going to be our hk point. So our hk is 1, 7, and now we need to choose an xy point on the graph so we can actually figure out what our a is going to be. So when you're choosing your xy point, it doesn't matter what point you choose as long as it's on the graph and it is not your hk point. If you choose your hk point to try to figure out your a value, you're just going to get 0, everything's going to cancel out, and it's not going to work. So you need to make sure that your xy point is just any other point on the graph other than hk. So in this case, they did give us another point themselves, and they gave us the point 2, 9. So that's going to be the other point we're going to use. And what we're going to do is just plug everything into our g of x right here and solve for our missing variable. So our g of x, that's our y value of 9, and that's going to equal our a term that we're solving for, times the cube root of our x value, which is 2, minus our h value of 1, all plus our k value of 7. So remember, the k value is going to be outside of the cube root. So what we need to do now is we need to solve for our a value. So we're going to minus 7 on both sides. And when we do, we get 2 will equal a times the cube root of 2 minus 1, which is 1. The cube root of 1 is 1. 1 times 1 times 1 is still going to be 1. So that just becomes 1. It kind of just goes away. So we have 2 equals a. So our a is 2. So all we need to do now is put that into our g of x. So we have 2, g of x equals 2 times the cube root of our x value minus h of 1 plus our k value of 7. Remember, your x and your g of x, or your x and your y, those are variables. So you do not want to put in your xy point into your last function or into your answer. You only want to put in your h, k, and your a or your b value, whatever you're solving for. Your x and your y points stay outside of your function answer. So that's how you solve for a. Let's go on to b. On b, we're going to do the same thing, except we're going to be solving for b this time. So again, first thing we want to do is figure out our hk points. So if we look at the graph, we can see that we kind of go along this line pretty normally, and then we shoot up right at that 2, 1 point, and then we keep going back normally. So at that point, when we start shooting up more, it becomes a lot more steep, and the graph becomes a lot more vertical than before. That's going to be where you find your hk point, and it's going to be right in the middle of when the graph starts to become a lot more vertical. So in this case, the point that we have is 2, 1. So let's actually do this a lot. So our hk point here is 2, 1. So we have our hk point. Now we need to choose an xy point. I'm going to say it again. It doesn't matter what point you choose for your xy point. It just has to be on the graph, and it cannot be your hk point. They gave us another point we can use at 5, 2. So that's the point we're going to use, 5, 2. So we're going to plug everything into the equation, and we're going to solve for our missing parameter of b. So our g of x or our y is 2. That will equal the cube root of 1 over b, that's what we're solving for, times our x of 5 minus our h of 2. All of that plus our k value of 1. Remember, the k is outside of the cube root. It's not going to be underneath the cube root. So we're going to solve for our b now. So we're going to subtract 1 over. We're going to add like terms first. We get 1 equals the cube root of 1 over b, and 5 minus 2 is 3. So 1 over b times 3. So what we need to do now is we need to get the b out from underneath that cube root function. So what we can do is take the cube of both sides, right? We talked about this before. If you cube a cubic function, they both cancel out. The same way if you square a square root function, they cancel out as well. So we're going to cube both sides, or really just raise both sides to 3. 1 to the third power, or 1 cubed, is just 1. And the cube root of 1 over b times 3, all to the third power. The cube roots and the third power cancel each other out. Like I said before, the same way a square root and a square function cancel each other out, a cube root and a cube will cancel each other out as well. And we're left with 1 over b times 3, or just 3 over b. Now we're going to multiply both sides by b. The b's cancel, and we're left with b equals 3. So our b is 3. All we need to do now is put it into our equation. So g of x will equal the cube root of 1 over b, so 1 over 3, times x minus h of 2, plus our k value of 1. So remember, your x and your g of x, or your y, you do not put them into your final equation, because the x is a variable and g of x is what you get when you plug in any x variable. So the x and the g of x are going to be changing, so you leave those as variables of x and g of x. You only put in your h, k, and either your b or your a value. So that's our answer for number 2. I want you guys to work number 3 and number 4 on your own. I'll give you all a few seconds, or really a few minutes. Pause the video if you need to, and I'll post the answer up in a few seconds. All right. So for number 3, this is what you should have gotten. Your b value, your hk value should have been -2, -5. And that's because if we look at the graph over here, we're going along normally, and then we shoot up, and then start going back to our normal slope, I guess you can say. Right, that point when we start shooting up, this point right here, this part right here, that's where we're going to find our hk. When the graph starts to shoot up more vertically, that's where we find our hk value, and the middle point there will be our hk. So we see that when the graph starts to shoot up, our hk point that we see is -2, -5. So that's going to be our hk point. Our xy, it doesn't matter if you use -1, -3, or 6, -1. It doesn't matter which point you choose, you'll get the same thing regardless. Because they're both on the graph, so either one you chose, you would have gotten the same same a value that I got of 2, and you would have gotten the same function, g of x equals 2 times the cube root of x plus 2 minus 5. So let's go on to number 4 now. On number 4, you should have gotten an hk point of -3, +2, and again, that's because when the graph starts to shoot up more, or when it starts to change shape, become more vertical, the middle point there is going to be your hk point. In this case, it happens to be -3, +2. Our xy point, you can choose either -1, +3, or -5, +1. It doesn't matter. Either point you choose, you would have gotten the same b value, and you would have gotten the same equation that I got of g of x equals the cube root of 1 over 2 times x plus 3, all plus 2. And our b value here will be 2. And remember, our equation is 1 over b, so it becomes 1/2 in the equation. All right, so let's go on to the next part of the video, modeling with cube root functions. So we can use cube root functions to model real-world situations, and what we're going to be doing here is we're going to be rounding to the nearest 100. I think I'm going to be rounding to the nearest 10th. It really doesn't matter all too much. Just on the quiz or test or anything, just listen to the instructions. If it says round to the nearest 10th, round to the nearest 10th. So if it says round to the nearest 100, do that. But in this video, I'm going to round to the nearest 10th. I'm going to go that way. Just because usually on quizzes and tests, it usually will be round to the nearest 10th rather than the 100. So anyway, this problem here tells us the shoulder height, h in centimeters, of a particular elephant is modeled by h of t equals 62.1 times the cube root of t plus 76, where t is the age in years of the elephant. And we're going to graph the function, examine its average rate of change over the equal t intervals of 0 to 20, 20 to 40, and 40 to 60. Pay attention that those are intervals of t. They're not actually points. And then we're going to see what is happening to the average rate of change as the t values of the intervals increase. And then we're going to use the graph to find the height of when t equals 35. So what we're really going to be doing is we're going to be using this equation that they gave us. H of t equals 62.1 times the cube root of t plus 76. We're going to use that function right there to fill out this table. All right. So we have our t values right here of 0, 20, 40, and 60. We're going to plug these into our equation, and we're going to solve for our h of t, or your y value, to finish up this table. So our first t value is 0. So you want h of 0, which will be 62.1 times the cube root of t is 0 plus 76. We're going to solve this out. The cube root of 0 is just 0, and 0 times anything else is 0, so all this right here goes away. It's just 0, so 0 plus 76 is 76. Next, we have h of 20. So that's going to be 62.1 times the cube root of 20 plus 76. So a problem like this, we're not going to expect you guys to be able to do this by hand. So you will be able to use a calculator when you're dealing with problems like this. So all you really want to do is put this into a calculator. Don't try to do it by hand. Chances are you're going to mess up or not even know what you're doing, because this is going to be pretty hard to do on your own. So just put it into a calculator, and when you do, you're going to get 244.6. All right, so once you get to these other uglier numbers, just put it into a calculator and solve it that way. Now for when t is 40, we're going to get 288.4. And when t is 60, h of t is 319.1. So again, just plug them in like we did before with 0 and 20. Put in 40 and 60 in the same way, solve it out through a calculator, preferably. And when you do, that h of t that you get, the h of t that you get is going to be what you put into your table. So we finished up our table. It's already graphed for us, so we don't need to worry about that. And what we need to do now is we need to figure out our average rate of change in between the intervals that they gave us. So the first interval that they gave us is 0 to 20. Or from this point to the next one below it. So we want to figure out what the average rate of change is from 0.76. Sorry about all the emails that you're hearing. So we're going to go from 0.76 to 244.6. So remember, the average rate of change formula is going to be f of x2 minus f of x1 all over x2 minus x1. So that's our average rate of change formula. It's very similar to the slope formula because it is pretty much a slope formula anyway. And the 2's and the 1's, what they stand for is just the order that the points come in. So f of x2, that's going to be the y value or the f of x value of the second point. So 244.6 minus f of x1, or the f of x value or the y value of the first point, which is 76. And all of that will be all over x2, which is the x value of the second point, or 20, minus x of 1, which is the x value of the first point, which is 0. And again, we're not going to deal with trying to do this by hand. If you have a calculator on hand, you're going to be able to use a calculator on this quiz. Just put it into the calculator. Don't risk making any mistakes. And when you put this onto a calculator, you're going to get 8.4 when you round to the nearest tenth. And I know the top is hundredths, but we're going to do tenths for this video. And it doesn't really matter. You can have a calculator anyway. You should be able to round to the hundredths if we ask you to do that instead. For the second interval, that's going to be this interval right here that they told us in the problem, 20 to 40. or from this point right here to the next one. So from the points 2244.6 to the points 40,288.4. We want to find the average rate of change from the first point of 2244.6 to the second point 40,288.4. So again, we use our average rate of change formula. So f of x2, or f of x of the second point, which is 288.4, minus the y value of the first point, or f of x1, or the f of x of our first point, which is 244.6. All of that, all over x2, which is 40, the x value of the second point, minus the x value of the first point, which is 20. And again, just put this into a calculator. Don't risk any mistakes. Don't make your life any harder than it needs to be. You put it in, you round it to the nearest tenth, you're going to get 2.2. And now we have one last interval to do. That's the third one. They want from the x value of 40, sorry, the t value of 40 to the t value of 60, or from that point to the next one. So it's going to be 40,244.6 to the point 60,319.1. We'll use our average rate of change formula again. That's what we have to do to figure out our average rate of change. So it's our second y value of 319.1 minus our first y value of 244.6 all over x2, which is 60, minus x1, which is 40. The second x value and the first x value. We put this all into a calculator, solve it out, round it to the nearest tenth. You're going to get 1.5. That's the average rate of change of this interval. We're rounding to the nearest tenth. So we have all three of our average rate of changes for each interval that they asked us to find. And now we need to look at it and we need to kind of compare them and see what's happening to the average rate of change as the t's increase. So we can see as the t's increase that our average rate of change is decreasing. So the average rate of change is becoming smaller. It's becoming smaller, or in other words, it's decreasing. And the last thing this problem asks us to do is to find the shoulder height when t is 35. It wants us to use the graph. So if we start at t equals 35, and we just go upwards so we hit the graph, that point right there is going to be our average, our approximate h of t point when t is 35. That's going to be about 280. And you can double check yourself if you want to. Just put in 35 into the equation that we started with. Be 62.1 times the cube root of t plus 76. And if you do, I don't remember off the top of my head, but I think it's about 279.6, something like that. But anyway, it's going to be about 280 anyway. And that's what we approximate about the graph anyway. And that's what we got. So anyway, guys, this is the video. I'm not going to go over number 2 and number 3 on this video. You will have completed notes online. You'll have the answers to that online on the completed packet. So you can double check your work there. There is no problems like these on the homework for this day's homework. And I think there's only one problem similar to this on the Module 11 review anyway. So I would take this chance to do number 2 and number 3 on your own. Understand how to do it and double check your work with what we have on Canvas. All right? So anyway, guys, that's it for the video. Hopefully this helped.